All right, welcome back. That was a quick 10 minutes, Tobias.
Yes, I'm pretty sure it wasn't.
I barely had time to get my hair cut. But we're going to continue our conversation. What we did to set up the class, we started out with some basic commands, just kind of make sure everyone understood what we were talking about. And if you hadn't heard some terms, in the recent past, I wanted to make sure everybody was comfortable with some of the terms. Did some basic select statements, and we moved into the second module where we talked about a little bit more. We started adding things like distinct and order by. So we did some sorting, some filtering, and kind of took it up a notch. What we're going to do in this module is talk some about the data types, because those are a very important part of data integrity and referential integrity, is making sure when we create our columns, when we're creating our tables, and for instance, that we have the appropriate data types applied to them. So we're going to talk about the different data types that are available to us, the usage of the data types, how I may want to convert a data type from one to a different one. Not every one can be created. And then we'll do an introduction in some of the SQL Server functions and types of functions that are available for us when we're working with SQL Server 2012. So we're going to introduce these data types and built-in functions. Let's begin with data types, because this is very important when you're adding your content or creating the objects that are going to be created here. And they kind of fall into seven general categories: exact numeric, approximate numeric, date and time, character strings, Unicode characters, binary strings, and then some other ones that kind of fall into the other catch-all here. So these are supplied, SQL Server supplies several built-in data types within these categories, like ints, so integers or characters or dates or binary strings. So we're going to begin by talking about exact numbers. So when we're looking at precision, or we're looking for the idea of having an exact number, we have a tiny int which is 0 to 255. So you know if there's a value or a field that's never going to exceed 255, you can use tiny int, and you notice it only stores or consumes 1 byte of information. If you have small int, that goes up to 32,768. So a value to that, or minus 32,768. So if you're going to store a value in between that range, you can do a small int, 2 bytes of storage. And I'm not going to read the entire slide to you, but you'll see the idea here: tiny int, small int, integer, big int, quintillion. I didn't even know there's a quintillion word out there, but that goes up to quintillion something or another. We have bits. That's a 1, 0, 0 that's always returned to us. Decimal or numeric, when I'm concerned more about the precision. Money and small money. They must be looking at my paycheck for that one. So those are some of the exact numeric types. And here's an example. I could declare a variable called myDecimal as a decimal with 8, 2. So that's going to define what number of decimal points are available, and what kind of content, or to what the precision we can store content in there. So we declare these items, and we have to take into consideration what kind of content is going to be stored in there. We also have the approximate numerics, where we introduce the float or the real, and depends on the type that you're using or the value you're storing. It's anywhere between 4 or 8 bytes for the float. It's 4 bytes for the real. So it's good for you to understand as you're deciding what data types to use for the content that's going to be added to your data, the storage size that's going to be consumed, and the type of data that you're going to be storing in those columns as you identify those columns and those data types. Under the binary strings, we have binary n, which is anywhere between 1 and 8,000 bytes. Var binary, variable binary, 1 to 8,000 bytes, plus 2 for storage, if you're looking at the number of bytes, plus 2 for storage. And we have var binary max, 1 to 2.1 billion approximate bytes. So actual length, what actually you're storing there, plus 2 additional bytes for storage. So
that may vary a little bit.
That may vary a little bit. Talk to me about that. Why would that vary?
It depends on how we store these binary large objects. So if you store less than a certain amount, there will be plus 2 bytes of storage. But if you extend past a certain limit, we'll have to structure the data differently, and you'll pay a bit more of an impact on storage.
Okay, so just good to know is watch some of these little tidbits like that may not, there might be some variations to what we're seeing here because of the type of content that's actually being stored. Other data types, we have unique identifier, for instance, a global unique identifier. Now, that global unique identifier, the GUID, how do you pronounce that?
But you're the American, right?
Yeah.
I'm a humble foreigner, so
I'm going to put you on the spot here. Is that how would you say that acronym?
GUID?
GUID. Okay, good. I always pull this no matter where I teach. I hear GUID most places, especially in the eastern United States, and I hear GUID more in the Midwest and some of the southern parts of the state. So I always ask.
So now we've extended this. In Sweden, it's GUID as well.
It is GUID? Okay. So
GUID.
now,
yeah.
Okay, so it's either GUID or GUID. I'm always curious at how people pronounce it. So just curious, just make a mental note. Do you yourself call it GUID or GUID? And just, so when you're talking to people, some people will say GUID. I'm like, what's a GUID? I have a friend that says, well, it's, how do you pronounce squid? Well, squid is a word. It's not an acronym. So I use GUID, and I was just curious what you used. So that's good to know. Anyways, back on topic. We have cursors. It's really not a storage data type, but we'll see how we use those a little bit later on. Tables, we'll use those as a data type. So it's not a table that we've been talking about where we store content in. You're going to see with some of the upcoming examples where we actually use table as a result, where we can store result sets into it. So we have some unique other data types that we use, like row version is another one that we have available to us that we can use when we're generating content here. Parse is a new function that was introduced in 2012 that converts strings to date, time, and number types. Is this replacing anything, or is this new functionality?
No, this is net new functionality.
Okay, so nothing's going to go away, or not. Like you said, we don't normally rip anything away from people, but nothing's going to be deprecated, or it's just a new functionality.
Yeah, correct. An important thing that we also added. Parse is converting basically strings to whatever other more exact data types that you have, and the typical example is obviously numbers and dates, right? So actually, I can go ahead and just show an example because it might be somewhat interesting, because this is obviously a common problem. By the way, this Cyrillic character I'll use for something else a little bit later, so don't worry about that one. So let's just say we want to go and select star from sales order header, and my favorite topic happens to be dates for whatever interesting reason. So let's just get the order date here. That's enough. Okay, so what the format I'm getting back here is dependent on what the client application, how it wants to format it. Now, this format I'm getting back is actually very, very nice because this is the ISO format. It also happens to be the ANSI format, year, month, day. And it's interesting, this ANSI, it's short for American National Standards Institute. But apparently...
I know where you're going with this.
Yeah, apparently here in America, they don't adhere to this standard.
We prefer month, day, year.
Yes, you prefer the one I can't get. That one and Fahrenheit I still struggle with. Anyway, so if I just want to go and convert something first, parse is obviously the other direction, right? So if I want to convert something to a date, in this case, I can say, okay, this ISO format, and let's see if I can remember the syntax using, and I can say here, well, we'll use Swedish culture, it's called, to parse this. So now it goes and apparently automatically now says, well, automatically obviously since I told it, but uses the Swedish culture, versus if I want to parse it using American culture, I can do that. And we support all cultures that Windows supports here. So now it happens to be, if we do both of these, we happen to get them correctly, and that's because we can figure out exactly what's being used here.
Nice.
The other thing that's interesting though is, what if I do this is hello in Swedish. That apparently is not a valid date.
Okay.
Now, an interesting thing that we added is try parse. And we do this for cast and convert that we'll get to later as well. That's basically, if it fails, don't fail the entire statement, return null instead.
Oh, nice.
So this can be very, very useful. For example, you can say, hey, where try parse this string in this way is not null. So now you'll get everything that actually can be converted or parsed into a date time. And the other one I wanted to show is format, which is the other direction. So parse is going from string to an exactor data type, and format is the other direction. So format this one as, let's see if I can remember what it is. let's say with Swedish culture, and there we go. Oh, okay, so that's the picture string. So this is now the picture string I want to format it using. I can add the culture as well, but now in this case I won't actually care about the culture. I'll just tell you, please give me year, then give me a colon for whatever reason, right?
Right.
Month, colon, day, space, hour in 24-hour format. And now that's exactly what I get back.
Nice.
So this is also super, super useful because now you can easily, in T-SQL and SQL, basically return the formats that you would like. And that obviously works for numbers as well.
Awesome. Yeah, that's a great demo. Definitely to see that. So datetime. So we introduced the general idea what the different data types that we have. Just kind of a high level in some of the categories. We're going to drill into character data types here, and there's really a couple of variations of that. We have the char and the varchar, and we have the Unicode, which is nchar and nvarchar. And then it looks like the text, the n text, are going to be deprecated. So we want to start leaning towards using the varchar max and the nvarchar max instead. So you're prepared for that. Now, when they say deprecated, any ideas when that may happen as the SQL product? What was your title? I mean, didn't you create SQL Server back in 1940 or something, 50 or?
No. I'm very young. And,
I'm very young. No, it was a compliment how smart you are.
No, that also not
1940 was
also not very 80. Smart. No. So I actually don't know the exact details of the deprecation plan for text and end text. Overall, we're very careful. Deprecation means you should avoid using it because we may run into problems in the future and we may have to remove it. So when we announce something for deprecation, it will stay in the product at least 3 releases. But after that, we may remove it depending on the need for removing it.
So I know a lot of people will see, it's being deprecated. I got to rewrite everything before the next release comes out. So that's why I was curious when I hear the word deprecated, no matter what product it is. Do I have to hit the panic button, or can I okay, I got a few releases before?
Yes, for SQL Server at least it's 3 releases.
Okay, awesome. All right, so we got character data types here, and here's their char and nchar, and it understands or introduces the char and nchar are fixed lengths, and we've got the varchar and nvarchar are variable lengths, and it gives you some storage information here. And it talks about the varchar max, the nvarchar max, in the storage requirements there.
So here I wanted to use just a brief demo with this Cyrillic character to just show the basically use of Unicode.
So that's a demo on the...
yes, so please, yes.
Well, you had that character in your screen that I saw earlier, and I just didn't know what it was.
Exactly.
So, yeah. So let's see what that demo is. Well, I got to see what this little odd character is.
Yes.
Well, not odd in a bad way. I just not seen it. Unique. That sounds better, right? I think it's better than odd.
Sure.
Special.
Sure. It's a character used by lots of people. At any rate, the most important thing here, this also comes from backwards compatibility, is if I'm going to use, so Unicode is it's a standard basically set of characters that is supposed to span basically all required characters around the world. Now this keeps extending and things change quite frequently, but overall in SQL Server you're safe. We support up to UTF-16, which is broad spectrum of characters. So at any rate, if I do this, right, again with the Swedish using the Latin characters, by default, or this string is now typed as an varchar string.
Okay.
Right. So whatever character set you installed on the database when you set the collation, that's what we're going to use. So in this case, this works just fine. But let's say I just want to add the Cyrillic character here. What happens now is we will go and try and convert characters that are not in this character set into the character set, and Windows has an API for this, and it will return ? If the conversion fails.
Okay.
So the important thing here to note is using strings like this is very dangerous if you use Unicode data, which you should do. So overall, you should definitely move to using nvarchar wherever you believe you will need other characters than the default character set installed.
Is there any extra overhead when using nvarchars or any of the
yes,
Unicode?
so
a little bit, right?
Basically, Unicode first we supported UCS2, which is 2 bytes per character. If you use UTF-16, which is a different collation, it uses sometimes it's called surrogate characters, and then you use 4 bytes for a given character. But at any rate, if I put a capital N in front of the string, now you'll see we'll handle it correctly.
Oh yeah. Okay.
So that's important. It's not just important that you use the right data type, such as mvarchar and nchar and mvarchar max, but you also need to type your strings this way.
All right. Awesome. Good stuff. Okay, so let's take a look at some of the things that we can do with strings. For instance, we have string concatenation, where we can actually merge, 2 different columns or multiple columns. In this case here, we've got the select business entity ID, first name and last name, and then we're going to concatenate first name and last name as full name. So when we run this, we're going to see business entity ID, first name, last name, and another column will be added over here, and that's going to actually display first name and last name as full name in a column. So we can do that. We also have introduces what's called concat function. This was what we're going to do here. Select address line 1, city, state, province ID. We're going to concat the address line plus city plus postal code as location. And we're going to grab this information from the person.address. And again, it's going to store that information. And what this will do, it'll convert nulls to an empty string before the concatenation. So you don't end up with some content in there, a row that doesn't contain anything that makes any sense to you. Now the cool thing about strings, just like we had talked about, we're going to talk in the next section here, like date and times, we have some functions that can be performed. So I can take a string and I can use like substring, for instance, and I can pull a section of that string out that it might be important to me. I can take a look at the length of the string. So if I'm trying to, hey, if the length of the string is greater than 9 or is equal to 8, I'll go out and perform some other task for us. We can change the case on it. So if a string comes in, it's lowercase, and I need to get it in uppercase, we can modify that string text. So we have these functions available to us to allow us to take content that we may have imported from a flat file, for instance, and we want to modify it, or we want to maybe extract certain portions of it to add it, or before we add it to a table. And we can use these string functions to perform some of these functions on character data types, for instance, before we go in and add that data. Now, Tobias talked about this a little bit earlier. I think we talked about the like. Maybe I'm confusing it with my other session, but the like predicate is used to check a character string against a pattern. So we use the percent sign for example. It's kind of like a wild card. So I want to go out and find anything with the name that has N. What did we use? We had mountain in here before. It was MOUNT, and then we'll put a percent sign in there, and it'll be a like. So I think it begins with mount, and it'll actually return anything that begins with a mount and any number of characters to the right of that. So it could be mountain, for instance, and it could be, I can't think of another word with mount beside on the end of it. But so that'd be an example where we could use that. If you're trying to just use a single character, replace or just a wildcard for like a single character, it's an underscore instead. So this gives us flexibility to return results or look for results or retrieve results that we're not 100% familiar with, or may not know the exact spelling, or may be spelt differently. And it gives us some flexibility of writing queries that allows us to query the content without knowing exactly what it is that we're looking for by either using the percent or the underscore as an example to return that content. And there's an example down below where we're returning the product line name and product number from the product table, where name like mountain percent. So anything to the right of mountain, because you might have mountain bikes, you might have mountain lions out there, and this will return anything that contains the word mountain and any number of characters to the right of the word mountain. So it gives us some flexibility when we're performing these select statements.
And with regards to performance, it's just interesting to note that if you have an index on the name column in this case, we can still use the index and seek through the index to find mountain something. Whereas if you put a wildcard in front of the word, we won't be able to use the index for seeking. We have to scan the entire index. Now, if you need it, you need it, but it's worth noting that
there's some overhead.
There's definitely overhead with using wildcards in the beginning of the string.
Okay, character data types. Let's see here what we have for demos. Do you have anything you want to show, Tobias?
Yeah, well, I already shown the Unicode
you did the
thing,
cool
right?
stuff. All right, let's see here. Yeah, okay, that's cool. That's true. That was probably the cooler thing anything I've gotten here to show them. So let's go ahead and talk about date and time data types. We did a little bit of a demo on that. We would do some conversion with the parse. But we have some data types here. Older versions supported date time and small date time. We now have date time 2, and date time offset that we can use that were introduced in SQL Server 2008. But we can use these for determining the type of date or time or a portion of the date and time that we want returned to us. So some interesting or new data types that were introduced for us that allow us. And again, notice the storage. For the date time 2 that was introduced, 6 to 8 storage bytes. If you go back to the old date time, there was 8 storage bytes for that available. So,
and I can show a quick demo here, which is important for you guys to know when you still use date time, because that's obviously going to be the prevalent data type out there, date time, rather than the new data types, even though they definitely offer benefits. So one thing that's important to know is its precision is down to every 3rd millisecond. So this is important in queries, right? Because a very common query is give me everything for the day, right? So get all orders greater than midnight, greater than or equal to midnight, and less than less than or equal to the end of the day.
Yeah.
Now, if you do less than next day, that's the safest bet. But just to show you what can happen here is I'll just use a string here and I'll say, okay, and cast is another is a function just for converting. So I'll say, okay, what is it today? The 13th, and then 23, 59, 59, and then you have milliseconds in there, so you will go naturally and say this, right, as date time. But if I go and execute that, that's apparently tomorrow, right, because the last millisecond will be 0, 4, or 7. So this means that if I go 999, it will round up naturally and correctly up to the next second. If I do 998, we'll go around down to 997. So 997 in date time is the end of the day. So that's just an important thing to know when you use this data type. And again, if you just say less than tomorrow, if that's your predicate, you're obviously safe. But it's an important thing to know of.
All right. So date time, data types, literals, and this is an example of where we just actually do a query of a sales order ID, and where order date equals a specific date. And these here are date times, and they have language neutral formats and some examples of these right down. It's amazing how they go down to the milliseconds nowadays and for information.
Or even nanoseconds, right? Date time 2 and time, yes.
Yep, that's
down to 100 nanoseconds is the max precision that
100 nanoseconds. That's amazing. That's really good to be able to do that. Working with date time separately. Here's where we get an example where we have the declare date only, date time, and then select the date only. Notice it returns, at this point, it returns just the date and nothing to do with seconds. It just uses all zeros for the seconds as if it's midnight. If I did it the opposite day where I'm looking just for the time, the date's going to be set to January 1st of 1900, and then you'll have the time for that portion. So just some ideas and awareness of different returns that you'll see, results that you'll see depending on what you're trying to do with the date and time.
And it's obviously more efficient than to go and use just our new date data type or time data type if you're just interested in storing a time or a date.
Querying date and time values. Again, we've just seen how to query one of them. They're talking here about values are stored. Queries need to account for time past midnight and dates. That's pretty much what you were just talking about with the precision of that item there. So we won't spend too much time on this, but it's good to understand what the options are and take advantage of those new date and times. Some functions that we can grab get date, which grabs a current date and time. There's no time zone offset for that. We do a current timestamp, which does the current date and time. Sys date time grabs a current date and time. And then we have sys date time offset. This does include the time zone offset. And you can use just a simple select current underscore timestamp, and it'll return that information for us. We also have date and time functions for date name. Use year, month, day as the date part. We have year, month, date as date part. We have day, month, and year. And all of these are items that we can do to extract the portions of a date out to return that information about a date that we might want to drill down to and get into some more detail of. Some additional functions that return date and time from parts. Here we have returned a type of data, We have datetime from parts, datetime to from parts. We have the offset from parts, and different items here. The functions that return date and time from parts, and you have some examples down below on how these would be completed for us as well. Some additional examples and functions that modify. We can do a date add where we want to add intervals, a specific number of days, for instance, as we're seeing here. End of month, we're trying to look for the end of month for a particular start date. Date diff, where we're trying to determine the difference between two dates. So I want to know how long a project is taking, so I have the start date, I have the end date. I can determine the number of days it took for that project to complete by using the date diff as an option here. The is date is available to determine whether a date or time is a valid value. It contains an actual valid value when we're adding these dates and times here. We had just seen an example that Tobias did with using the cast option here. Here's an example of that. Select cast sysdate time as date, as today's date. It can return an error if the data types are incompatible. So if I'm doing a select cast sysdate and I want to return that as an integer, we're going to get a little bit of feedback on that, as in explicit conversion from data type to int is not allowed. So again, you can convert the different columns or different data types. Not everything is convertible to every other type of data type, so you have to be aware of what can be converted from one data type to another data type, or one data type to another data type, and understand what those are before you start going out and trying to use the cast or the convert commands for performing those conversions. Here's the convert command here. Can be used in select and where clauses. Another example, select convert char8 to a current timestamp. And here's the ISO style we talked about earlier, about how we can determine how we want that date to be returned to us. What style do we want to use? In this case here, we're using the ISO style. So date and time function data types. Are there any other cool date time function demos you want to see, you want to show?
No,
that we haven't discussed. We had examples. I don't know if there's anything that's unique that would...
Not really. Well, we talked about the every third millisecond. The other thing that's more interesting as an anecdote is that the date time data type starts at 1753. So if you want to store dates before 1753, you would have to go and use the date or date time to or date time offset data types. It has to do with the 1753 is when basically the British Empire moved to using the Gregorian calendar rather than the Julian calendar. So that's why this 1753 was picked.
Okay, 1753. I'll have to remember that. All right, we have some built-in functions that we can look at and take advantage of as well that are available to us. And some of these include the scalar functions, grouped aggregates, windows, and row sets. And these are how we're kind of categorizing these by scope of input and type of output. So if we take a look at scalar functions here, we've got items and categories. We've got configuration, cursor, date and time, security, string, system. And these can be used for us to be able to perform functions on these types of data. So here's an example of a date time function where we're doing a select sales order and grabbing the year from that particular date. A mathematical function, looking for the absolute value. We're doing a cast. We've already seen that one. A metadata function where we're doing something, we're selecting database name as current database. So if you're working in or programming and you want to be able to retrieve the current database that you're in, you can use this select DB name, open and close paren, it will return that current database that you're working in. So it's a good way to determine where you are to make sure you're executing the commands that you want to execute in the appropriate database here. Some Windows functions that we have the rank function. We have offset, we have aggregate and distribution functions. This here is doing a select top 5 by product name or of product ID, name, and list price. We're doing the rank and over and order by, and we're going to by list price, and then we're going to do that, return that in descending order. What's the rank by price? What's that? Or the rank? What's that going to provide for me?
Yeah, so window functions overall are super interesting, and it's one of these things that you need to spend a bit of time playing around with and thinking about to kind of get into the groove of how you use them. But once you do, you'll never want to go back. Right? They are super useful. Let me actually show a few examples, because this one I know we got some feedback on the chat where you want me to go a bit slower. This one I'll go. Definitely, it's very good feedback. But this one you'll have to take away that you'll need to spend some more time with to actually get into the groove of it.
Yeah.
But I'll show you some examples. Let's just look at kind of a common thing. Let's say we go and select star from sales order detail, and we'll pretend this is kind of like a transactions table for a bank. And let's just do this for a specific customer ID. Or let's just do this. Okay. And order by, let's say order date. Sales order detail ID. Okay. Ooh. Oh, sorry, there's no order date in here. I'll just do this. Okay. So first of all, one thing that you may be interested in your set, just returning a row number. So which order of the row, which row is this in the particular set? So I can go and just add here and say, well, give me the row number. And it's kind of like a ranking function, or it is a ranking function, but rank would give you, if multiple values have the same, multiple rows have the same value, you get the same rank. Whereas row number, you'll always get a new row number, even if they're returning the same value. So I'll say, okay, give me the row number. And obviously, row number makes no sense without actually knowing the order. And select, again, is executed before order by, so you can't really use whatever is in the order by clause. Plus, you may want to have multiple row numbers because you're calculating something. So the actual function uses this over clause to know about the ranking. So order by, and I want this, let's say, ordered by sales order ID as row num1. And let's just run this. And you can see we get these row numbers that now start adding up. What I can also do is say, well, I don't just want row numbers, I want row numbers per order. So then I can add the partition by clause, partition by sales order ID, which will mean for every order I'll get new row numbers as they start as they basically reset. So we see here the row num1 keeps increasing while row num2 keeps resetting as I get into a new order, right? So that's what row number does, and that's what these kind of functions do, is you tell them based on the set, this is how you do your calculation, and you do row number, rank, dense rank, and so on. The other thing that's interesting to mention here is on aggregate functions. Now we'll get more into grouping later, so group by and so on. But aggregates are very useful together with as window functions. So, or using the over clause rather. So let's just say I want the sum of unit price here. Now, if I try and execute this, we'll complain and say, oh, why do you combine an aggregate with all of these non-aggregate functions? Because what does this mean? You want the sum of unit price per what? Well, you have no grouping, so it would be the sum of one value. That doesn't make sense. But what you can go and do is you can say, give me the sum based on something. So I can now tell it, well, I actually want this sum partitioned by something. So sales order ID. And then we can say as total order price. And as you can see now, the total order price will be the same for all of these rows that adhere to the same order, right? So in this case, this aggregate is actually run across these rows based on the window that you define. So the partition by clause defines the window for this calculation. So for each partition has its own window that it calculates over. What I can also go and do is say, well, I would like also the total price across all orders. So over everything. Ooh, now I managed to zoom it.
You zoomed way in.
This is great.
Wait to come out.
And now I can draw something here. Hello. Okay, stop, Mr. Zoom it.
There you go.
Okay. This is very interesting. Yeah, that's I have tried Control 1. That doesn't seem to. But it doesn't want to go back. Okay, let's call this demo finished. You got an introduction into window functions, and we'll see if we'll get back to it a little bit later as I try to figure out what's going on with my machine here.
Yeah, the last piece I wanted to talk about is that we can use the choose option here. Then we're going to wrap up this module here. We can do this option. We can use this option. So select choose 3. And we've got 3 items in the list here. We've got beverages, condiments, confections as choose result. And then we can choose the different items that we want to choose. So just a way to kind of create it's kind of a hard-coded list, but a list of items that we can choose to work with. We did some cool built-in function demos. So we're going to just kind of wrap this up. SQL Server associates columns, expressions, variables, parameters with data types. Bottom line, when you create a new table or a new object, we need to understand the type of data that's going to be stored in there. It's not to be taken lightly because you have to make sure that you're able to store content, the appropriate content. This will enforce data integrity. And you also have to understand how that content's going to be used. For instance, if I enter a character field, I'm not going to be able to perform any calculations on that. So you have to understand what type of data is going to be stored and the type and the purpose or the use for that data. And we introduced 7 categories of built-in data types, as you can see here, exact number, binary strings, date and time, character strings. And we talked about some of the functions that are available for the strings, specifically the left, right, the replace, the upper, lower, if you want to change the casing of it, and a substring. We talked about the like. Specifically, I can use the percent as a wildcard to the right. Behavioral different if you use a left, especially when it comes to indexes. And that will be any linked a number of characters for that wildcard, underscores for a specific character. So let's say, for instance, state code. I know it begins with A, but I can't remember if it's AZ, for instance. And I can't think of another state code all of a sudden. And it begins with A. WA, there we go. So we have options.
It begins with A.
No, it begins with A, yeah. So another state code. Here's Arkansas, whatever that one is. AR, I think. What is it? AK.
Oh, that's great.
Whatever it may be. Obviously, I need to pick up on my geography here, but we can actually use A underscore, and that would replace just a character, or do a wildcard search for a character. So I know I want a state code that begins with A. Obviously, I don't know my state codes. I know AZ because that's where I'm from, but apparently I don't know the rest of them. Several date-time data types available. Some of the newer ones that we talked about, the date-time 2, the date-time offset. Make sure you take a look at those. Try to utilize those. We're down to nanoseconds for those. Also, we have some functions associated with those date times, like getDate, current timestamp, sysDateTime. So we can use those types of functions for us to be able to retrieve content that we're looking for, specifically to dates. So we talked about some scalar functions, kind of introduced those briefly, as well as grouped aggregate. We got a really cool demo on Windows functions from Tobias. That was really cool. Some other functions we just briefly talked about are like choose. And so it's good that we have these functions that allow us to work with these data types when we choose to work with these data types. So this is a way for us to introduce the idea of what data types are all about, how important they are for us to choose the appropriate data type based on what type of values are going to be stored in there, and what maybe calculations or tasks that we want to perform with the data that's stored in there. And then we talked about some of the different functions associated with the different data types, like the character data types or string data types, the date-time data types. We introduced some of the functions available for us to extract content or portions of those to retrieve and use those portions in a result set as an example. So what we're going to do is we're going to break for 10 minutes. And when we come back, we're going to go into our next module. And the next module, we're going to talk and get into more detail about understanding more about different options we have for advanced queries with SQL Server 2012.